Hi, I'm Nicolas Gomez, and in this little video I'm gonna show you how to read manometers. So first of all, this is an instrument that is basically used to measure the pressure of a gas. So before starting, you should know the different types of manometers: an open manometer and a closed manometer. Here you can see that both ends of this U-shaped instrument are both closed. Here there is one end that is open to the atmosphere. So in order to calculate the pressure of a gas, you should know the equation: the atmospheric pressure plus or minus the height difference of both sides is equal to the final pressure of the gas. So in order to calculate the gas pressure when it is lower than the atmospheric pressure, you first of all have to notice the 800 millimeters of mercury of one side and the 100 millimeters of mercury on the other side. So this means that the atmospheric pressure is being stronger because it's pushing down the liquid inside the manometer. Okay, so in a case like this, you should always find the height difference first. So 800 minus 100 equals 700. This is the height difference. Every time that the atmospheric pressure is stronger than the gas pressure, you should always subtract. So using the equation that I told you before, 760 minus the height, in this case 700, is equal to the gas pressure, that in this case is 60 millimeters of mercury. In a case that the gas pressure is stronger than the atmosphere, this means that this side will push the liquid downwards. You should always add. So first of all, as always, find the height difference. 700 minus 200 is equal to 500 millimeters of mercury. This is the height. Okay, since the gas pressure in this case 300 plus the height 500 is equal to 800 millimeters of mercury. So this is the total pressure of the gas. In every problem you would encounter, you should always get the atmospheric pressure. So in this case, it is given to us, it's 300. Okay, now reading a manometer that is a closed manometer is very simple. You just have to find the height difference, and that will equal the gas pressure. So the pressure of the gas is equal to the height difference. So here 700 millimeters of mercury, and here you have 200 millimeters of mercury. So the height difference will be 700 minus 200. It will equal 500 millimeters of mercury. So the total pressure of the gas would be equal to 500 millimeters of mercury. This is simple due to the fact that this end of the atmosphere is closed, so no atmospheric influence, no atmospheric pressure influences in this manometer. In some cases, the atmospheric pressure would be exactly the same as the gas pressure, as you can see over here. So this means it has. So for example, if this right here is 500 millimeters of mercury, you just ignore the fact of the height difference. So 500 plus or minus 0, it's equal to the gas pressure. So in this case, it would also be 500 millimeters of mercury. So you just ignore the idea of the height difference, because there's actually no height difference. So when you have a case when both ends are the same, but it is a closed manometer, the gas pressure will obviously equals 0. So the pressure of the gas is equal to 0 millimeters of mercury, due to the fact that since this end is not being affected by the atmosphere, the pressure does not push downward, meaning it doesn't have a strong pressure. So the pressure of the gas will be equal to 0. So this is these are the ways in which you can interpret a manometer. And a manometer, again, is an instrument to measure the pressure that a gas has. And so yes, this is it, and I hope you understand.